Hi, now I'm going to explain about periodic functions, which is it is very significant in the area of electrical and electronic system. If you want to study about the signal and wave or wireless systems. Okay, now what is periodic functions? Okay, the graph of periodic functions like sine and cosine repeats forever and are called periodic functions. Okay, meaning that if you have graph that repeat the same pattern, dia akan berulang-ulang pattern yang sama, itu adalah periodic functions. Okay, now these are two examples. Okay, look at the first graph. Okay, if you can see the word period here, period refer to the complete cycle, the distance, yeah, the distance untuk dia repeat semula kepada bentuk yang sama. Okay, jarak dia adalah di sini. Okay, it can be anywhere in the graph. Let's say kalau saya letak di sini, saya mula di sini. Okay, so the period is, okay, saya tak boleh berhenti di sini, and it should be stopped here. Okay, because if you observe here, let's say this is point A and point B and C. Point A is start to decrease and point B increase, which is bukan pattern yang sama. So C is decrease, yeah, and then we can conclude that the period is from A until C. Okay, yeah. And the second graph, the one cycle refer to the period lah, yeah. Another period is here, yeah. If you see here, kalau mula di sini, okay, dan dia akan repeat semula pattern yang sama pada X2. Okay, ataupun let's say you want to find the period from X3. Okay, X3, dia akan mula repeat pattern yang sama X4 pada X4. Itu another period, ya. It can be anywhere, yeah. Okay, a periodic function can also be defined as an equation in the form fx plus np equals to fx, meaning that if you can prove the left hand side equals to right hand side, and then you can conclude that the function is periodic, yeah. For example, you can prove that sine x plus 2 pi equals to sine s, and then you can conclude that the function is periodic. Okay, now we go to the first example. Okay, before that, okay, if t is the period of function, then the period of function of the form is given by the period of trigo function over p. Okay, the period of trigo function refer to the sine, cos, and tangent, meaning that the trigo function, the period of the trigo function, it could be either, if your question is sine, so it should be 2 pi here. Similarly, if your question is cos, you should put 2 pi up here. If your question is tangent, and then the period of the trigo function should be pi. Okay, and the modulus of b, okay, refer to this general form. Okay, this, okay, the b is here. the B is before the X. Okay. Okay. Now, example 4.1. Show that ft equals to cos 2 pi t is periodic function, and then find the period t. Okay. As I told you, you can say that the function is periodic if you can prove that ft equals to ft plus large t. Okay, now this is ft cos 2 pi large t. Okay, and then equals to cos 2 pi. Okay, now here after t we add another large t. So t plus large t. And now you need to apply trigonometric identity. Okay, this one, use this. Okay, so sorry, the second one, not the first one. Okay, then I should have, okay, we refer here. Okay, now our A and B is small t and large t. Cos 2 pi t plus t equals to cos 2 pi t cos 2 pi large t plus sin 2 pi t sin 2 pi large t. Okay. Now how to make the left hand side equals to the right hand side? Okay. Now left hand side equals to right hand side only if this part is 1 and this part is 0. Okay, so we put condition left equals to right if cos 2 pi t equals to 1 and sin 2 pi t equals to 0. Because if sin 2 pi t equals to 0, 0 multiply sin 2 pi t equals to 0. So this part will be equals to 0. Okay, and then cos 2 pi t, if it equals to 1, 1 multiply cos 2 pi t, and then we have cos 2 pi t. So they are equal. Okay, then we can conclude that the function ft is, you can conclude that ft is periodic function. Okay, how about the second question? Find the period t. Okay, the second question, we use this formula. Okay, period t equals to, okay, this is cos the period is 2 pi over b here, and b, if you look at here, b is before x, near the x. So but now our question is t. Okay, so your b is here before x or before t. Yeah, your b is here. So your b is 2 pi. Cancel out. The t is equals to 1. Okay, similarly, the next question is show that fx equals to sine 3x is periodic function and find the period of t. Okay, now the first step is you must prove that fx equals to fx plus t. Okay, so our fx here is sine 3x, and if we plus t, sine 3x plus t. Now we use a trigonometric identity, which is the first one here. Okay, equals to sine 3x cos 3t plus cos 3x sine 3t. Okay, and the left hand side equals to right hand side only if cos 3t is 1 and this part is 0, meaning that we put condition left hand side equals to right hand side if cos 3t equals to 1 and sine 3t is 0. So if sine 3t is 0, if this part is 0, 0 multiply cos 3x will be 0. And if cos 3t is 1, 1 multiply sine 3x equals to sine 3x, and then equals to sine 3x. Left hand side equals to right hand side. Okay, now so we can conclude that the function is periodic function. Okay, now how to find the t? Okay, use the formula t equals to, we use the formula, this formula again. Okay, for sine the period is 2 pi. Our question is sine, so the period is 2 pi. And b is here, a value before the x, or t, which is 3. Okay, our formula here is modulus of b. If we have negative, make it a positive. So the t is 2 pi over 3. Okay, that's all.